Hello, everyone. Welcome to the seventh Bevy Game Development Meetup. I'm super happy to be back. This was quite a long pause from the last meetup in summer, and yeah, now it's winter here, and I'm super excited for our meetup today. So let's quickly go through our typical presentation. We're gonna have today again 3 amazing speakers, great topics. I'm super excited about that. We're gonna keep it simple, short and sweet, 15 to 20 minutes presentations, and plenty of time for Q&A for everyone. Please find the link to the Q&A platform in the stream description or on the meetup page, or I'm going to also paste it into the chat in a bit. So as a reminder, as usual, the stream is recorded and will be made available afterwards also in individual video form. And the code of conduct, pretty Rust typical: be kind, be respectful, and be curious. We come here together today to learn and to find out about people's projects and what's going on in the Bevy community. And yeah, if you have any concerns, if you find anything that you think is against this, then please reach out to me. Don't hesitate at all with that. And yeah, who am I? I'm Stefan. I'm hosting this now for the 7th time. I couldn't be more excited. I'm with Rust already since 2017, 17 years of game development experience. And yeah, you might know me from my open source projects, Git UI and LifeAsk. And this year, for this meetup and for more Rust-specific consulting, I founded Rust Unit. We are building Rust games and consult in any Rust software out there. So feel free to reach out via our Rust Unit website. And here's another chance to scan the QR code. It will be in the corner of the stream for the entire time. So feel free to join in on the live Q&A there as well. And now, I'm actually going to pull my video away, and I'm going to put our first speaker for tonight on stage. His name is Zach. You might know him as BushRAT from the Discord. And he's going to talk today about his gigantic effort of making Bevy no-stud compatible. I couldn't be more excited. So let's put him on stage and give him a big hand. Hey, Zach, welcome. Yeah. Here are your slides. And let's hear why this is so important and what we will all get as a benefit from this effort. Thank you for being here, Zach, and I'm going to leave the stage to you now.
Awesome. Well, I'll say good morning to everyone. It's currently 5 a.m. over in Australia, so you'll have to forgive me if I'm a little bit misspoken this morning. Still getting myself woken up. So consoles and beyond, making Bevy no STD compatible. So first off, just a little bit about myself, as Stefan mentioned, and again, thank you for the introductions. My name is Zach. You probably know me as BushRAT. That's my little user profile in the top corner there, if you recognize that. I'm an electrical engineer and a software developer, and I'm currently based in Tasmania. And my pronouns are he, him, for those that are concerned about that. So, onto the topic. But first, why no STD compatibility? That's the first question that I get asked when I start proposing this unit of work. But before I can answer why no STD compatibility, we should probably take a step back and actually define what no STD really is. But before I can do that, I want to go one step further back than that and actually talk about what the STD library actually is. I think we all have some preconceptions as to what the STD library is, especially if you are familiar with Rust from a long-term perspective. So we've got things like results, the box, print line, iterators, all the things that we use in Rust typically come from the standard library. But there's a little bit more complexity here that Rust hides behind the scenes from us. There's actually 3 smaller crates within the STD library. So if I take those same items and just sort them into those 3 categories, you can see that we've got something called core, something called alloc, and then something that's confusingly also called STD. Now, this isn't a comprehensive list. This is just a visualization of that breakup. So I want to go through what these three crates are first. So what is core fundamentally? This is the bare minimum functionality to get what most of us would call a Rust experience. So, and most things that are in the standard library, you'll actually find are in the core library instead. So this includes things like result, option, and even some of the more high-level abstractions like debug for printing, the iterator traits, most of the iterator combination methods like chaining and zipping. All of these things actually come from core. To kind of illustrate just how big core is as a crate, this is a screenshot from docsrs. And I've just drawn a little arrow up into the corner there, that side, to show just how long this list is. It's a huge crate. So then what's left? If core is so big, what's in these other crates? Alloc is the next one. Alloc, based on its name, is allocation-related functionality. So this is where we get things that need to interact with runtime memory. So boxes, vectors, arcs, reference counted pointers, basically anything that needs to touch the heap, if it's a more fundamental type, comes from alloc. Another important thing that comes from alloc is the actual allocator trait itself. So how a Rust program can ask for memory at runtime. And then finally, we then get STD. STD within STD provides operating system integration. So this is where we get some of the really high level functionality from Rust. So working with files, working with networking, multi-threading, time integration. A lot of that functionality then comes from STD itself rather than core and alloc. Time is an interesting one because we get duration from core. So we get the difference between moments in time from core. But to actually get an instant, you need access to the standard library, because to know what time it is, you need to ask somebody. And that somebody is typically the operating system. So with that overview, I can answer that first question. What is STD? It's core, alloc, and STD. So then following that, what is no STD? Just core and alloc. There's a bit of debate within the Rust embedded community as to whether you would say that alloc is a part of no STD. The reason why there's a bit of a debate there is that you can run alloc on any platform that supports core, but you need to provide an allocator. And normally the platforms that you would run no STD code on are embedded type platforms where you just don't have a lot of memory to play around with. So why would you make an allocator if you've only got, say, 1 megabyte of memory to spare to play around with? For my purposes, I'm going to include alloc as a part of no STD though. So with that sort of boring definitional stuff out of the way, why are we pursuing no STD? It sounds like we've got a lot of functionality in STD that Bevy would rely on. Obviously, files are how we get assets. Multi-threading, incredibly important for game performance. Why would we take all that away from Bevy? The important thing is that we're not taking these things away from Bevy. What we're doing is making them optional within Bevy. By making them optional, we can now take Bevy and make it compatible with a platform that does not have the option of providing that functionality. So the key here is that we're going to retain all existing functionality in Bevy. Nothing gets lost. But what we gain is new platform support that we previously just could not have. And I'll get into what kind of new platforms shortly. Another key benefit for moving to no STD is it's an opportunity to go back over old and established APIs within Bevy and refine them. This separation from what's STD and needs the operating system versus what's core and doesn't need anything, and what's alloc, where you need allocator functionality, that split pulls apart a lot of our existing APIs and exposes some really nice boundaries. And even though on a modern computer, you would have plenty of memory to work with an allocator, so you wouldn't need to care, for a game, allocation can be pretty expensive, depending on where you're allocating and why. So having that exposed and pulled apart makes it clear, oh, that bit of code has allocation happening in the middle of it because it needs alloc to work. So let's not use that bit of code in a hot loop. Let's pull that out off to the side. So stepping back, what kind of new platforms do we actually get access to with Bevy? Well, the typical that I've mentioned before is embedded platforms. So Arduino, ESP32, Raspberry Pis. These are the poster child for the embedded community within Rust. But there's a bit more to it than that. For example, when Rust gets ported to a brand new platform, think Redux for the Rust operating system, the standard library usually comes later than support for compiling in Rust. And the reason for that kind of makes sense. You can't have the standard library until you can compile in Rust. So support for compiling in Rust comes first, and then the standard library comes second. So for experimental platforms, that's nice. But that also includes platforms where getting a standard library made is actually quite challenging. For example, the current generation of consoles are supported by the Rust compiler. They're just x86 CPUs, so we can compile for them right now. But there's not a standard library crate, at least publicly, available. There might be one privately available. I don't have an NDA to know that bit of information. So by removing that STD requirement, we've now got the possibility of compiling for those platforms straight away without any caveats. But those aren't actually the reason why I personally have started pursuing this initiative. The reason why I started pursuing this initiative is I had recently discovered that there are crates on crates.io for working with retro consoles. So if you look up crates.io right now, there's a crate called AGB, and that allows for compiling games for the Game Boy Advance. Not the Nintendo DS, not the Nintendo Switch, the Game Boy Advance. And I find that as a concept just absolutely mesmerizing, that Rust, this brand new language, not even 15 years past stable, you can take that same bit of code that we're writing for brand new high performance computers and just compile it all the way down to running on a console that's going on 30 years old now. That's incredible to me. But the Game Boy is not the only one there. There's platform crates for the PlayStation 1, PSX, and there's even crates for working with the Nintendo Switch, but in a homebrew context. So that one's called NX, or Nintendo Switch. Those kinds of crates allow us to compile and run games in very esoteric platforms, but they don't support the standard library. So if we could make Bevy no STD compatible, suddenly it's not just Rust that we've got available on those platforms. We've now also got a modern high-performance ECS-backed game engine and all of the community that comes with that game engine available for those platforms. And I find that, honestly, I'm stunned at the idea. I would never consider running, say, Unreal or Unity on a Game Boy or a PlayStation 1. But there's a distinct possibility of running Bevy on those platforms. And I think that that's a testament to the flexibility and power of not just Rust, but Bevy in particular. And then that last one that I've got noted there is just running on a computer, but with no operating system at all. So there's a platform crate called UEFI that allows for writing a bootloader in Rust and actually booting up onto a bare metal computer without Windows, without Linux, nothing. So if you're really wanting to prevent cheating in your game, I guess you could make a complete no operating system game in Bevy using this kind of initiative. So I'm hoping that's covered the why and the what, but how? It sounds like it might actually be a really challenging project to try and take a big game engine and make it compatible with such small, restricted hardware. But it's actually not as complicated or as challenging as I had initially expected, which is fantastic. There's really only a handful of things we need to do. The first is we just need to refactor some of our existing code. So the actual first fruits of this initiative was enabling a handful of lints that are already available in Clippy that just warn the developer, hey, you're using something from STD. It's actually from Core and Alec. Go use it from Core and Alec instead. And that's a very small change. It doesn't actually change the functionality of any code, but the important thing there is it highlights the places where we need STD versus where we're just happening to use STD because the name's convenient. So that bit of work has actually already been merged into Bevy and should hopefully be coming out with 0.15 when that comes out soon. So that's already done. We've got a nice refactor already handled there. The next major item is we still want to have Alec and STD compatibility available to us. So we need to add features to all of the various crates in Bevy that re-enable STD and Alec functionality. And then the last item there is dependencies. That one's a little scary because obviously we don't have direct control over all those dependencies. Those are their own projects. So it's a little rude for me to go over to a project and say, hey, you make yourself no STD compatible. But thankfully, the Rust ecosystem already cares a great deal about no STD compatibility. In fact, out of all of the crates that I've been working with Bevy right now, more than, I'd say 3/4 at the moment, are already no STD compatible. It's only a handful that are actually requiring STD. And even in that handful, a smaller subset of those don't have a no STD alternative ready to go. So where are we right now? Well, to get what I would call a bare minimum no STD functionality for Bevy, so something where a user can just cargo add Bevy to their no STD project, we need to have these 6 crates fully ported over to no STD compatibility. So these first 2, Bevy Pointer and Bevy Utils, they're already done. So that's why they're highlighted in green. The next 2 are Bevy Tasks and Bevy ECS. I've highlighted them in orange because the pull requests for making these no STD compatible are already published onto GitHub, and they're currently just waiting for 0.15 to release before they get fully reviewed and merged. Hopefully merged. I shouldn't speak too far ahead into the future. After that, it's then Bevy App and Bevy Core. Bevy App and Bevy Core comparatively are very small crates to get ported as well. So we are very close to having a bare minimum no STD Bevy experience. I don't want to commit to any timelines, but I am aiming for 0.16 to be a no STD compatible Bevy release. So if you're really interested in this functionality, I've got the ID of the tracking issue for a GitHub issue that I've opened up that just covers all of the little units of work, because this is really a lot of small changes that need to be made to Bevy, not one large change. One big pull request to make Bevy no STD compatible would be a nightmare to try and merge and get everyone on board with. So if you're really interested in some of the more technical details on how we're doing this and the progress we're making, I really encourage you to check out this tracking issue on GitHub. We also recently opened up a working group in the Bevy Discord, if anyone here is familiar with the working group system. So please check that out as well. Now, I've got a little bit of extra time here, and I've sped through this a little bit because I've got a couple of demos that I was hoping to show. So let's see if I get cursed with live demonstration woes. So I believe, yes, cool. Okay, I'm just double checking the stream to make sure that everything's all working. So this is a Bevy application that I've written that is completely no STD compatible. This is currently using a fork of Bevy that I'm working on that goes the extra mile and fully makes Bevy app and Bevy core no STD compatible. And I really want to highlight that despite a couple of scary looking symbols up here, like, oh no, there's no STD, and why do I have an entry written here? These, if you're from the no STD world, this is just the common parlance. We have to do some extra dancing to get Rust to play nicely on these platforms. What I want to focus on, though, is down here. We create an app, I add some plugins, and I run it. That Bevy plugin there is just a standard Bevy application. So add some plugins, set my runner, add some systems, order them appropriately. This is what I believe most people would be familiar with when they think of what's it like to write Bevy. And so if I run this bit of code, give it a moment, this is a small Bevy application that is running on bare metal hardware. And it's opened up on my other monitor. So this application here, for those that aren't familiar with it, is QEMU. So this is running a virtual machine, and this is my Bevy operating system running on bare metal. And I've got keyboard controls, so I can speed this up, add this little Bevy logo bouncing around. I think that's amazing. That's fully controlled in Bevy. That's 100% Bevy code with one crate brought in to add compatibility with UEFI so that it can boot straight onto raw hardware. So I'm going to close that one. That keyboard shortcut. There's a second demo. I don't really want to show the code for it because it's a little, well, actually, no, I will show the code for it. I was going to say it's a little ugly because I only got it working last night. So this one here, it's another small Bevy application. It should hopefully look fairly familiar. We've got a plugin that I'm adding here, some resources, some systems, and then I run my Bevy app. This application is actually currently running right now. I don't know how well it's going to show up on the webcam, but it is currently running on a Raspberry Pi Pico driving a e-paper display. And it's probably too hard for me to show up on the screen, but down the bottom here, it is showing how much heap memory it's currently using, and it's using 63 kilobytes of memory to run this whole application. So I think what I want to illustrate with those is that this isn't a hypothetical set of features for Bevy. This is a very real and potentially very soon set of functionality for Bevy, if everyone wants it, of course. So with that, I would like to thank everyone for taking the time to listen to me. And I'll hand it back to Stefan there. Thank you all very much.
Hey, Zach, thank you so much. Amazing stuff. Yeah, I'm still flashed by seeing this Bevy logo on your Raspberry. Amazing, amazing. I can't wait to see Bevy rendered low level, I don't know, IoT stuff. Like this shows me basically that whatever screen we have, no matter how small or what kind of matrix kind of simple screen, we can run it and power it by Bevy, right? Yeah, we have a bunch of questions. They're voted for, so I'm going to start with the most pressing one, and then maybe if we can't get through all of them, we're going to talk about the rest in like a little panel conversation at the end, right?
Mm-hmm.
This is actually one that is like 3 questions in one, and I'm also very curious about when did you start using Bevy? When did you start with the no-stud effort? And how hard was it actually to get into the code base to do this deep work?
Yeah, so I think I've been using Bevy for, I think I'd say about 12 months, I think now is probably a reasonable estimate, just as a hobby. So I'm not currently doing anything professional or any games anytime soon. Right now, I just love writing Rust, and Bevy is a great excuse to write a lot of Rust. So, and who doesn't like playing with games? I believe the second question was how hard it was to jump in. Or
no, let's start with when you started with the no-stud effort.
Oh, sorry, when I started with no STD. I believe that's only 2 or 3 months old now.
Wow.
So this is a very recent initiative. It started during the 0.15 release cycle, which is why it's not a part of 0.15. Well, not all of it. Some of the changes that I've made are in 0.15. So Bevy Utils, for example, that's now no STD compatible for 0.15. So that's a new thing that's coming there. So the fruits of the labor are already starting to show up.
Nice.
And I believe the last one was how hard it was, or how hard it is. Amazingly straightforward. The biggest thing we have to do is annotate Bevy crates with no STD. And then the compiler says, well, if you're going to do that, and then highlights everything that's wrong. And it's a very mechanical process of just going through, okay, I can't use vec here because I don't have the alloc feature. Okay, this requires alloc. Now it compiles. It's a very mechanical process of just going through Bevy and letting the compiler tell me what's wrong. The hardest things that we've had to change so far are there are a couple of core dependencies that Bevy relies on that aren't no STD compatible. The big one's petgraph, for example. So we use that in the scheduler for organizing the order that systems are run in and making sure that it makes a coherent graph. That crate isn't no STD compatible. But making a no STD compatible alternative just for Bevy ends up not being too much work. It's around a few hundred lines of code added to Bevy to replace some of these dependencies. We do need to be pretty selective, though, about what we include. So Bevy render, for example, that relies on WGPU. That's not coming to no STD. There's a few things here where I draw a line in the sand and say, no, that's not happening. But the core functionality of Bevy, the ECS, the plugin framework, and then further from that, things like Bevy color, Bevy transform, a lot of the functionality that Bevy relies on, users of Bevy rely on, don't actually need the standard library. It just happens to use it because it hasn't been a problem before. Well, it's still not a problem, but I'm making it my problem.
But one follow-up to that. So you mentioned that once you see it uses something like VAC, you just slap alloc on it, right? But do you also come across places where you wonder, like, do we really need the feature XYZ here that makes us require alloc, and therefore, with a little bit more refactoring, it could get alloc free, or is that like a later problem once the first batch of work is sort of done?
That is exactly the kind of thing I was referring to, and I was saying we get to refine some of our APIs. So it actually has been a couple of cases. So in Bevy Utils, there was a little function that just shortens the name of a type. to make the debug prints a little prettier. And that function needed string, and it needed to allocate memory in order to be able to take the name and shrink it down. But it actually didn't need to. With a little bit of refactoring, it could just write the short name from left to right without needing to allocate another string. So in that instance, didn't need to say, well, sorry, can't use it. You need the alloc feature. It was able to just refactor that little bit of code. And the big benefit there is now no STD platforms get to use that code. Yay. And on STD platforms, that code no longer allocates. So now it wasn't necessarily hot path code before, but it is more performant now that it doesn't allocate. Yeah. So both sides of Bevy get benefits from this initiative.
Yeah. That's really cool. Okay, I think we have time for one last question before we have to come back later. Not sure how serious that is meant, but I guess the underlying gist is clear. Has anyone run Bevy ECS on a toaster yet? And I think you already kind of showed the example at the end. It is something like that. Is there any other interesting use cases that you've seen that you didn't do yourself yet?
So I did see, I've seen some people mention the idea of making arcade cabinets using Bevy. You could do that with a full-size computer, but the embedded world has better support for working with things like joysticks and buttons and custom electronics. So I've seen that and think that's really cool. But I also have seen some people talk more seriously about the idea of, oh man, it'd be so nice to have the ECS framework for their little embedded IoT projects, like being able to use it as the scheduler and being able to use it to manage resources and everything. So there has been some interesting ideas that have been proposed, but I think this is something that's new enough as an idea that there isn't a fully fleshed out list of what can we do now? What does this unlock?
Yeah. Okay, gotcha. Yeah, that's so cool. So Zach, like I said, let's come back at the panel at the end for the remaining questions. I would like us to move on to our next speaker. Thank you so much, and I'm pretty sure you get a big virtual hand from the chat out there. And please keep the good work up. I can't wait to have more functionality being available in Nostode, and obviously the long-term dream of being able to port these platform-specific SDKs that will require us to have not a dependency on the Rust standard library. Thank you so much, Zach.
Awesome. Thank you very much for having me.
Okay, we are back, and now we're gonna have our second speaker of tonight. Let me pull Bryan up on stage. Welcome, Bryan.
Hello.
So I'm going to give the stage to you. I'm super excited to hear in detail how you can build your own Rust linter, and in your specific case, for our Bevy specific needs, let's say, right? So big hand to you, and you got the stage for you.
Awesome. Thank you. Okay. Hello, everyone. My name is Bryan. I go by BD103 online. I started contributing to Bevy shortly after 0.12 was released, around about a year ago, I guess, at this point. And I have a strong interest in infrastructure and tooling and documentation, specifically related to Bevy. What this means is that you're never going to see my name on the release notes for any Bevy release. But I will be in the background working on CI, working on documentation, doing all the fun things that make it easier for other people to build the Bevy game engine. Some things that you may know me for is I wrote Bevy Bencher, which is a benchmarking integration that basically tracks Bevy's performance over time. I wrote Flag Frenzy, which is, if you've ever heard of Cargo Hack, it's like that, but on steroids. It is a program to test combinations of feature flags in a crate for crates that have dozens upon dozens of features, and how those all play together. And I also wrote the majority of the Bevy 0.14 migration guide. So if you happen to read through that and found it useful, then that's awesome. Glad to help out. Some other things that I didn't take full responsibility for, but I've also helped out with, are the Bevy contributing guide, and I help maintain Leafwing Studios' cargo cache action. If you ever use GitHub Actions with that, as it's pretty popular in some templates. Okay, with introductions out of the way, let's get started. This is a seemingly innocent piece of code, but it has a small issue with it. One so egregious that it will cause programs to lag and eventually crash if run for long enough. Can you spot where it goes wrong? I'm just going to give you 5 seconds at this point. And if this init resource line was the thing that caught your eye, then congrats to you. This piece of code is deceiving because it actually works as intended by the original author. The person writing this probably intended to register my event as an event that they can send between systems using the event writers and readers. And they succeeded. Doing this will work. If you pull up a new Bevy project and you try that, it will work. You'll be able to use events. But something is missing here. If we compare this with the correct form of registering event using the add event method, you will notice that, well, one thing that you won't notice immediately, which is part of the problem, is that init resource doesn't fully set up events. Init resource does not register the system that deallocates old events, meaning that old events will live forever and will cause a memory leak. So if you use the incorrect code, you will have a memory leak in your game that will slowly build up more and more memory as more and more events are sent, until eventually you check your task manager like, oh, hey, I'm using 15 gigabytes of memory when my game only should use half of one. What's going on? So because of this, the event structure is a foot gun. It is something that can be misused really easily. It appears to work as intended, and it's really easy to discover by beginners. It's in the Bevy ECS prelude, so you already import it by default. And it looks like it's a resource. It's something that's taught to you as part of the Bevy Quick Start. So you immediately think, oh yeah, this must be how things are done. Discovering the add event method is actually a lot harder because that is different. That's weird. It's not part of the ECS by default. And additionally, using the init resource method is something that's only problematic over time. When you're developing a game, when you just get started, you're never going to notice a memory leak because that's something that only happens after playing your game for an hour. So events can be misused pretty easily. And there are a few solutions that we can have to this to make it harder to discover by beginners or harder to misuse. And of these, my personal preference would be to quasi-deprecate it. You can deprecate something by adding the deprecated attribute to it. Then anytime any other piece of code imports it, it'll have a little error that says, well, it'll have a little warning that says, hey, this API is deprecated, as well as an optional message that you can specify. This deprecation warning forces the user to explicitly silence it, which makes the user consent, like, I understand what this does, I understand why it might be dangerous, and I know how to use it correctly. This should be enough to dissuade new beginners from using it. But unfortunately, deprecation in itself is a different message than what we're trying to say. You see, if somebody gets a deprecated warning, they're not going to see, oh, this API is dangerous, I should be careful. No. Instead, they're going to think that this API is going to be removed in a later release. That's what deprecation means. That's us saying, oh, hey, yeah, this API, we used to have it, but we don't really like it anymore, so we're going to get rid of it. We just want to let you know that that will be happening in the future. But unfortunately, the deprecate attribute is the only way to communicate really anything to the user. But even then, it's not what we're trying to do. It's not the full solution. So what do we do in this case? Where's the middle ground? Where's the solution to prevent beginners from using events, but still allow professionals, people competent and with a in-depth knowledge of the event system to still be able to use it? Well, that's where I come in. Over the past 2 months, I have been working on a project that solves this exact kind of problem. It is Bevy Lint, an experimental linter, just like Clippy, specifically for Bevy projects. This linter integrates directly with Rust-C's libraries, with the Rust compiler, meaning it benefits from all of Rust's amazing error messages, and it can handle all Rust code by default. We're not building anything from scratch. We're building off of the existing code in the compiler, which means it should integrate smoothly with your project. But how does that work? I didn't fork the Rust compiler. I'm not injecting my own version, building my own toolchain. How could one actually use the Rust compiler libraries within your own program? Well, first, this requires installing a nightly Rust toolchain with RustUp with the Rust-C dev component. The reason we do this is because it includes this specific file, librustcdriver.dilib or .so or .dll, depending on your platform. This is a dynamic library, or a shared object for my fellow Unix fans, that contains the complete compiled form of the Rust compiler's crates to be easily linked and imported into your own projects. You don't have to build the compiler yourself. You don't have to modify the compiler because it already builds a library form that you can import yourself. But first, let me show you a magic trick. I will recreate all of the Rust-C executable in one single Rust file. May I have a drum roll, please? Oh, that's good enough, given how I don't know how to play audio from Google Slides. That works. Anyways, enough stalling. Here is all of the Rust-C executable in one single file. Yeah. It's not that impressive of a magic trick, nor was it really magic at all, but this displays my point exactly. To use Rust-C libraries, you need to use the Rust-C private feature at the top of your crate. This is the equivalent of a terms and conditions document that says, things may break at any time. Don't expect the mighty Rust compiler devs to bow to your puny mortal wishes. But once you've scrolled through that and don't read it, you sign your name or whatever, and you're free to use any Rust compiler library that you wish, just given that it may break at any time you upgrade to a new version of Rust. And with that, you can use Rust compiler libraries. And of those libraries, well, there are a lot of them. So much so that I could probably spend the rest of my talk just detailing each and every one of them. But I'm not going to do that, because we're here to talk about linters. We're here to talk about how people can improve their code, not how the Rust compiler devs thought to organize their program and how that's grown over time. So instead of talking about that, let's go a little bit deeper into using the compiler programmatically. Well, I previously showed you this snippet of code for recreating the Rust-C executable. If you want to use Rust-C libraries yourselves, you likely don't want to use this directly, because this doesn't provide you any means to configure the compiler. Instead, you'll likely have a program that looks something like this. This is as compared to a main function, uses the run compiler structure, which allows you to specify the command line arguments to your program and a set of callbacks that will get run. Let's go into that a little bit more detail. Callbacks are a way to give functions to the Rust compiler that it will then execute at certain times in its compilation process. For instance, the config method in a callback is executed at the very beginning of compiling, when things are just getting configured. While the after analysis method is a callback that is called once everything's all lowered to HIR, everything's type checked and borrow checked. So that is called once that you know this is valid Rust code that I can begin turning into a binary. And then you could hook your own code to do certain stuff at that point. For us, callbacks are represented with this trait, the callbacks trait. We pass a structure that implements this trait to the compiler, and it then calls it at a specified time, at specified times, as mentioned before. If you wanted to, let's just say, analyze the compiler's internal representation of your code, you'd likely want to override the after analysis method, because then you know you have valid Rust code to begin with. Stuff like that. Now, lints are a special case, because while you would originally think, oh, I'd run lints in the after analysis phase, well, not quite. Lints are special cased. You actually register them in the configuration step using the lint store structure, as you can kind of see here. You'll see I call lint store.register lints, and I pass an array of lint definitions. Then lint store.register lint passes, and I then pass in a lint pass. This is how you register lints, so that the compiler knows about it ahead of time, so it can resolve all the names. There's an option in the Rust compiler that allows you to print out all the different lints that are possible that you can reference, so it knows all that stuff ahead of time. But once you do that, you can inject your own lints into the compiler. But before we continue, I would like to clarify that a lint is not one singular thing, but in fact two separate things. In the compiler, the term lint, or specifically the lint structure, is an identifier. It is the definition for the lint, including its name, its group, its default level, warning level. It's the thing that specifies like the name that you use the allow attribute for. But the lint in the compiler does not say where this lint might be raised. It doesn't say how to find this lint. Where might it come up? That is where lint passes come in. Lint passes are a series of functions that check your code. And unlike lints, they can't be named directly, can't be disabled directly, but they can emit multiple different kinds of lints in a singular pass. So for instance, if you had two very, very similar lints, you would have one single lint pass that checks for them both at the same time. So that's a little bit of the clarification. And going further into lint passes, there are actually two kinds of lint passes that are representative of two different formats of how the Rust compiler represents your code. The first is the abstract syntax tree for the early lint pass. The abstract syntax tree is, if you were to, let's just say, try to write your own compiler, this is how you would probably model Rust code using types. But the thing about the abstract syntax tree in the Rust compiler is that it doesn't know anything about path resolution. It doesn't know about imports or other crates. It just checks that the keywords that you used and the symbols that you used are correct. But if you imported something from a crate that doesn't matter, the abstract syntax tree will not catch it. This is why early lint passes aren't all that useful for most kinds of lints, because usually you need type information. Usually you need path resolution in order to do true checks. This is compared to the high-level intermediate representation, or HIR, which is a step down from the abstract syntax tree, very similar, but everything's resolved, everything's type checked. You know that if some path's being referenced in the HIR, that path probably exists. So we have these two different kinds of formats, and in most cases you will use a late lint pass because it gives you type checking information, which is also useful. When you implement a lint pass, you have two options as mentioned before, and this is the second. This is the late lint pass. This is what it looks like. Usually what you do is you define a structure and you override certain methods for what specific things you want to check. And then when that lint pass is run, those methods will be called for every single kind of code that matches that. For a more concrete example, the check item method is run for all structure definitions, imports, constants, and functions within your code. That is a method that's run on every single instance of those. Well, another method, such as the check expr or check expression method, is run for every single expression within your code, within function bodies. So anyways, let's look back at the original example code that I gave. And let's pretend we were writing a lint for this. The first step that you have when you write a lint is you want to identify when it should actually be raised. What things could you do to cause it to be to pass, or what things should fail? In this case, you'll notice we specifically want when you insert the events resource. So we should look for method calls of app's init resource method, and we should check for the generic argument to be the event structure. That in the simplest form is what we're looking for. And now, while I won't go into too much detail because it gets a little complicated, this is what that lint may look like. This is extracted, so to speak, from the Bevy Linter, from our copy of it. And some things to take away from this code, while I won't walk you through line by line, I will lecture through that. Some things that to bring up are, you'll notice that lints and lint passes are declared with macros because there's a little bit of boilerplate behind them. But you can just treat the declare lint macro as creating a static, like a constant, but a static, and the declare lint pass macro creating just a structure that implements lint pass. You'll also notice that a lot of the lint passes code is pattern matching and digging through types and that kind of thing. This is because there's a lot of information that the compiler gives you. You can see a lot of different things, but usually it's too much. Usually there's dozens upon dozens of methods that you have to look through, and it's a bit of a struggle trying to find which one you actually want. So many things are nested layers upon layers of deep that writing it isn't the most challenging part. It's researching it and finding the APIs that you need that is most challenging. Another thing that you'll notice is that this linter code is optimized to return early. There's a lot of cases where I check if a specific condition is true, and if so, I just exit out of the code. The reason for this is because if this method is being run for every single expression in your entire crate, and if you're compiling this using cargo, then every single dependency as well, that could get slow really quickly. So because of that, we want to avoid as much unnecessary work as possible. If we have even a single slight suspicion that this lint may not occur, we exit out early because we don't want to slow things down. We want things to be fast so people can get quick feedback on what they need to fix. The final thing that you may notice is that emitting the lint using the span lint function near the bottom of the code, it doesn't specify the level of warning, that is. There are error levels, there are warning levels, there's the allow level. The reason we don't specify it in this span lint function is because while we can set the default, the user in the end gets to control whether a lint shows up or not. So all lints by default are emitted, and the Rust compiler afterwards filters through all of these lint warnings and figures out, should I display this? Should it be a hard error? Or should I just continue compiling and just display a warning? Or should I just not even say anything at all? And there's been a little bit of work by some compiler devs to make it so that not like lints that are allowed by default and never enabled don't run at all, but that's for another story. So let's take a step back from the deep depths of Rust compiler internals, and let's talk about Bevy Lint. What does Bevy Lint have to offer for you? Well, so far it has 6 lints implemented over the past 2 months that can help you check your code or require certain things. Not all of them are enabled by default. Several of them are restriction lints that you opt into if you want to require certain things of your code. But these are the things that we have available. I talked about insert event resource already. It checks when you insert an event resource as compared to using add event. But there's also things such as the panicking methods lint that allows you to basically deny calls to methods that could panic in like the query structure or the world structure. If you've ever used query.single or something like that, that will panic if the query doesn't match any components or if there's too many components. But panicking and crashing your game is not a viable strategy. So you can use the panicking methods lint to deny this and force your system to handle the result, handle the error if this can't be caught. Other things such as there's a lint to require that all plugins end in the plugin suffix, something that requires you to handle the app exit structure returned by app.run. Because sometimes the Bevy app can crash, but it doesn't panic, and so you'll see an exit code of 0, but when in reality there's an error that was caused. And other things like missing reflect. If you're tired of using let's just say developer tools like Bevy EGUI inspector that say, hey, I don't know anything about this type, but I know it exists. Well, you can have the missing reflect lint that will allow you to require that all components and resources within this module should implement reflect. And a few other things like the ZST query. If you query for a 0 size type, it says, hey, you're not actually querying any information. You should use the width filter instead. So yeah, those are the things that Bevy Lint has so far, and we have plans for another dozen or so lints that are going to slowly be added over the next few releases. But beyond that, that is all I really have to talk about. Thank you all so much for your attention, and I hope you found this tour of the Rust compiler interesting. While the compiler isn't hard, there is a lot. It just takes a little bit of learning, a little bit of a learning curve, but it is very approachable once you know where to look, once you start learning things as you go through. If you have a project made in Bevy, I would like to ask that you consider using Bevy Lint in your continuous integration or just running it once to see what your code's doing. Over the next few months, I would really appreciate a lot of testing to make sure that this works, because the plan is to eventually upstream Bevy Linter to be an official Bevy product if it is successful and tested in the field a lot. There are plans to add it to the Bevy engine's continuous integration checks for pull requests, so we can begin requiring stuff within the engine, like reducing panics, in order to make it out of the engine a better experience. And yeah, this is all in my eventual goal to claim my title as the subject matter expert of laundry. But until then, I'll just be Bryan hanging out and working on fun compiler stuff. If the specifics of how the linter works is of interest to you, please consider contributing. I hang out in the Bevy CLI working group on Discord, along with a bunch of other lovely people. The code for the linter is heavily documented, sporting an insane 2-to-1 lines of code per comment ratio. For every 1 line of code for every 2 lines of code, there is 1 comment matching it, which I don't think you're going to get in really any other project. But yes, that is all. Thank you so much for your time, and I hope you found my presentation interesting.
Bryan, thank you so much. This was a super interesting talk. We have actually a bunch of questions, so I want to get right into it. And the chat is giving you big hands too. So this was really exciting. So one thing that is asked here a lot is, does that require my project to run on Rust nightly to be using the linter?
No, it does not. but there is a little bit of extra work you have to put in to get it to work. Long story short, you can write your own. You can write Bevy programs in stable Rust and still use the nightly linter, because. Actually, mind if I share my screen to show the documentation for the linter, because that best explains it. Let me stop my screen here and present, share screen like that. And I think that should be what we want. Yes, here we go. So this
wait.
Yeah.
Here is your screen. Okay.
Sorry, I forgot about that. Okay. So this is the documentation for the Bevy linter. It's all in Rust doc, nice and easily. And one of the things that the Bevy linter does is whenever it's checking your code, it passes this -- config Bevy lint. So you can basically detect whether Bevy lint is enabled or not. Similar if you've ever detected if your crate is being built with docs.rs or something like that. This is how you can detect if it's being used. And because of that, you can use this to basically only use nightly features when Bevy lint is active. So it does mean there's a little bit of extra work if you want to, like, for instance, deny certain lints. You have to write this. You have to only enable that lint when Bevy lint is on. If you want to still use stable Rust, but it's not impossible. It's certainly something that you can do. And we're slowly working to get this a little bit easier and easier to use. So yes, stable Rust is possible, just a bit of boilerplate.
Yeah, gotcha. Cool. So the next highly voted question is, does that also mean we get automated fixes for offending code?
Yes, that is a big focus of the stuff that I've worked on. Just as, you know, there is cargo fix, that command, or rust fix as it was called. Lint can emit suggestions for your code. And some of those suggestions can be machine applicable, which means cargo fix can automatically apply those suggestions. So yes, there's a world where you can run the linter and it automatically fixes up your code. There was someone who brought up that this could be used to automate migrating your code to new versions of Bevy.
Oh wow!
It's not something that I think would be feasible in the short term, but over the long term, we have all the tools, we have all the data necessary to migrate. It's just the process of actually doing that in the amount of work that would be required for that kind of thing.
Yeah, imagine an auto migration for the new bundle free kind of spawning.
Oh, that's actually a good idea. I should write that down. That would be a really interesting.
The required components, yeah. Exciting. Okay, one last question. The rest I think we have to delay to the end of the last presentation. What's the process to decide what lint will be accepted even or added in the long term?
Yes, I'm going to go back to my presentation or my screen share to show you. We have an issue tracker. You'll notice that the Bevy linter is within this Bevy CLI repository. We have an issue tracker for things specifically labeled related to the linter. So if you have a lint idea, you can submit an issue here to say, hey, it would be cool if I could do this. And then usually what happens is I go and review some and I mark them for specific milestones that I think would be useful. Stuff like, I don't have any specific examples off the top of my head, but things like that. So mainly it is a mixture of community requests and different people saying how much they like something. For instance, the lint that we have that denies panic and query methods, Alice, one of the maintainers of the Bevy engine, she requested that explicitly because she thought that would be useful. And so that was kind of sped ahead and improved and worked on. But yeah, generally create an issue. And if people want to work on it, they can. And then there's just community debate, whether it's a good idea and what the specifics are. Yeah.
And I mean, I guess in the end, a lint that is not on by default is not going to hurt anyone, right?
Exactly. Yeah. Just like how Clippy does it.
Exactly. Yeah. Super exciting. Bryan, thank you so much for working on this, for
Thank you as
presenting
well.
this, for showing everyone how this works. One last thing that I personally would be interested in is like, I really appreciate that it's so well documented. I mean, this is something I can't highlight enough. But that also means that you're probably very welcoming to contributors that want to join in the fun and build on this linter with you. So
Totally, yeah.
they can also reach out to you on Discord, and you will help them get into the weeds of it, right?
Of course, I love mentoring people. So just tag me on Discord. It's BD103. Not too hard to find.
Perfect.
So yeah.
That's awesome. Okay, thanks, Bryan. Let's talk later in the panel discussion about the remaining questions. And I am going to put up a 1-minute break, and then we are back with our last talk for tonight. Okay, welcome back. We are heading to our last talk of tonight, and I'm going to soon put Co on stage. And yet again, we will have a talk about UI in Bevy, and I'm super excited about this one because I personally think the project where this is coming from, his own UI framework, is super exciting. And as we all know, the more we are building Bevy UI out, the more I think it is beneficial to all of us to have a diversity of input of all the different approaches of UI. So let's welcome Co on stage. Hey, welcome.
Hi, everyone.
Here are your slides, and I can't wait to know how we finally reach escape velocity with Bevy UI. Take it away, Co.
All right, so yep, I'll be talking about Bevy UI today. Let's see. So I think most people who use Bevy know that raw Bevy UI is tedious and verbose. This is a long-standing problem. And so for a long time, I have been searching for my own personal escape velocity in developing Bevy projects that include UI. So in this search, I've really come to understand that there's no single panacea that will solve this problem. Instead, it's a long incremental process of shaving off excess weight or streamlining the rocket, so to speak. And at a certain point, once you have accumulated enough improvements, that's when you cross the line into escape velocity. And that's, I think, personally, in my personal experience, that's what I've achieved with my project. So, and I'd like to share that with you guys. So here's the situation with Bevy UI. Generally speaking, writing UI directly in Rust has been improving over time. So we've seen a lot of innovation and experimentation in this area. So Sickle UI, I can't believe it's not BSN. Dreamer Talons projects, Bevy Deoxys, and so on have all been pushing the envelope of how easy can you make it to write the UI within Rust itself. However, I think many people recognize that there's a fundamental problem that in Rust UI cannot solve, and that's the curse of the recompile. The recompile loop to make changes and adjust things when you're doing UI is extremely painful, even if it's only 1 or 2 seconds gap. It disrupts your workflow, and it's importantly not editor compatible to have your UI only in Rust. So my solution that I developed in my crate is not surprisingly asset-oriented UI. And so I'll talk about BSN in the next slide. So the project I developed had these design goals. I wanted it to be painless hand authoring, zero pain, as much as imaginably possible. I wanted minimally destructive hot reloading, which means when you hot reload your asset with the UI in it, it does not destroy the scenes you've spawned. It only destroys things that must be destroyed. So if you remove a node, it will destroy the node. It'll despawn the entity. But if you change something on a scene node, then it will only mutate the existing entity. I also want the specification in the asset to not just be components, but to include arbitrary entity mutations. So things that look like entity commands. Within the assets, I wanted to be able to reuse data and patterns to support, to reduce duplication and to enable asset-driven widgets. I also wanted the whole framework that extracts the assets to be compatible with an editor that allows simultaneous hand authoring of files. So you can go back and forth. You could go back and forth between an editor and hand authoring the file. And since the file is painless to hand author, this back and forth should be natural. And so to bring it all together into the world of Rust, all scene logic needs to be easily added at runtime. So you spawn a scene and then you add logic to the scene that you've just constructed. And to do that, you need to be able to dig into the scene to get at the nodes where you need to add logic. And so I'd like to honorably mention Bevy UI crate, which is a pseudo HTML UI that has some similar design goals to me. And that crate actually really inspired me to make some recent major improvements to my crate. All right, so now we can think about, what about BSN? So why would I bother going through this huge amount of work when we've got BSN on the horizon? So there are a few things that really stick in my mind. One is that there are different design goals. So my design goals and the goals of BSN are not the same. And so that's a big motivator for me. So BSN appears, so as far as I can tell, is components only. Everything in the BSN scenes is going to be components. Whereas in my design goal is to include entity command like things within the scene structure. Hot reloading BSN, it sounds like the plan is to just wipe out whatever exists and then respawn a new scene. This has editor performance implications because if you are rapidly changing some value within a scene, then and to reapply a scene, you need to destroy the scene and reconstruct it. It might not be feasible actually to rapidly change values within the editor. That remains to be seen, of course. And also, it's really not clear at all how scene logic would be integrated with the BSN. There's been some talk about baking in the scene logic, so trying to add components that represent scene logic. And I find this, it's too entangled, I think, I feel like. We're also aiming at different feature sets. So as far from what I've seen so far, BSN is primarily a scene format that creates scenes, but the asset format I constructed, and I'm going to be showing you guys today, includes a lot more than just scenes. It includes commands and constants, and there's more stuff that has yet to be developed. Also, BSN is not available yet, and if it was available, maybe I would not have built this crate, but I want to find escape velocity for my own personal projects, which are, I mean, within the time horizon available, this crate was the best option. And also, finally, building cool tech is fun, and I had a lot of fun building this crate. So that makes it all worth it. All right, so here's a little introduction to Cob, the Cobweb asset format, which is found in the Bevy Cobweb UI crate. And so as you can see, the hot reloading works just great. And adding stuff is painless. I sped it up, but in the course of about 2.5 minutes of real typing, you can create a very ugly button, as you will see soon. And there it is, my ugly button. All right. So in developing this asset format, there are some key ergonomic wins. So if we go back to the slide and play a little bit, we can see that there is no structure around. So this is a scene. This is a scene here, but there's no braces for the structure. So scenes are only use indents to identify the scene layers. There's also no commas between fields in a struct. I simply shaved off all of the unnecessary things. Also, I added new type collapsing. So within the asset, when you have some complex structure, so you have an enum, that it's a new type enum that wraps some struct. And when you can collapse this so that you only need to write the enum variant and the the container. I also included built-in types so that you only, so since this is UI focused, we have val. Instead of writing px, the px enum, you just write px like this. I think it's really helpful to have that. And similarly, I added built-in hex colors for sRGPA. And all of these wins, these are all small increments that build toward a faster rocket ship, I guess. All right, so here's a little demo of hot reloading scenes. And so this hot reloading is non-destructive. So when I rearrange the nodes, it's rearranging the actual children of this parent node. So when I take the node out, it despawns it. And when I put a node back in, it spawns a new node in the correct, or a new entity in the correct position with the right scene content. So like I said, the hot reloading is minimally destructive. But to accomplish this requires there's certain restrictions, because if as I said before, the I want these things here, these loadables, to be not just components, but to be like entity commands. Or I call them instructions. So they have a mutable reference to world when they're applied, which means they can have arbitrary side effects. And so to support that, when you're mutating, when you're doing some hot reloaded change to an entity, you need to be careful that the side effects of any loadables that you previously had in there are handled appropriately. And so, yeah, the problems are, and then the loadable list, it might be a cumulative process. So since they're not single components but mutations, the full set of mutations might cumulatively result in something that is different if you reorder the loadables. So to solve this, my solution was, whenever a loadable is hot reloaded to be changed or to be removed completely, you revert the loadable. So for components, this just means removing the component. But for instructions, this means you have to implement a function that will undo any side effects of that loadable. So this is some cognitive overhead, I suppose. That is like as an alternative to the cognitive overhead of doing a primarily component-based approach, where you have to use systems or hooks to manage everything. And then so after you've done reversions on a hot reload, then you reapply all of the loadables onto the node. And that way the cumulative effect that you end up with after reverting and then reapplying is the correct final node state, ideally, unless you mess it up. All right, so we can move on to the next feature of the asset format. So this is the manifest section. So here we can see, oops. Here we can see that the file loaded into the app is main.cob, so this file here. And the scene loaded is loaded from the my scenes file. But my scenes is not here. So the manifest brings in this other file, scene.cob, over here, and gives it a manifest key, my scenes. So this is the manifest key here, is tied to this manifest entry in the main cob file. Oops, damn it. All right. And then when you hot reload the transitively pulled in file, it works as expected. All right. So manifests allow you to load cob files transitively, recursively, whatever. And they give you manifest keys so that when you load a scene, you can specify the manifest key instead of the file path. And manifest keys are also used for imports, which I'll get to in a later slide. So the next little feature is commands. Let's see here. All right, so we can see down in the command line that it is printing out this command, because the command itself is defined as just a print statement. It prints itself. And the only other thing to note here is that you have to register the type that you're going to load. But other than that, it's quite simple. You derive reflect, default, and partial eq, and then implement command, and then you have a command that will automatically run during startup once it's been extracted. So all commands are applied during startup. So it's not in the startup system, but it's in the very beginning of your app while extracting things. All commands are globally ordered by manifests. And this was a recent incremental progress I made in the development of this project. Globally ordering means that you can have commands that depend on other commands. So you could load an asset in one command that other commands later on reference. So you load this asset into some asset map that caches handles, and then later commands can safely access that map to pull in to pull out the handle, and it'll be the right handle. So when doing hot reloading of commands, we make sure to always wait for any pending files to ensure that all side effects of a hot reload, which could affect multiple files, is respected, and that the final global order of modified commands is changed. So if you changed some constant, as we'll see, that is used by multiple commands, when that constant change is hot reloaded, the backend system will wait until everything is done propagating to apply the modified or the affected commands that depend on that constant. And then similarly, scenes will wait until all commands have been applied after a hot reload to ensure that if a scene depends on some command, like if a scene references some asset that is loaded by a command, then the scene will properly wait and reload after the asset has been refreshed. All right, so we can look at constants now. These are very handy. So I pasted in the def section, definitions. I defined a constant green. It does what you expect. Here it goes. All right. So constants allow data reuse, and right now I have built-in assets, so embedded files in the crate that define all of Bevy's built-in colors. So we've got the Tailwind, CSS, Basic. I think there's another one. All those constants can be used from within COB files just by importing the built-in file. All right, so here's a highlight of what I was talking about before with how a constant can be used to reduce duplication of this PNG location, this file location, and it ties together multiple loadables, so command loadables or scene loadables that depend on the same string. All right, so we can talk about now importing, which lets you bring in definitions from other files. So this is separate from the manifest. The manifest says load this file, but the import says bring in definitions from this file. So we use the manifest key for imports. So here we're importing the Tailwind built-in file, giving it an alias, and then we can access the constants from within that file like this, and there we go. It changes the colors, and that was all hot reloaded. So very handy for accessing constants defined elsewhere. All right, so right, I've mentioned this before, but loadables are all of the blue items in the scene. So we got, these are all loadables here. Each one is a loadable. So command loadables and scene loadables are implemented similarly, but command loadables, of course, implement command. And scene loadables, there's three types. There's regular Bevy components. There's reactive components from my other library, Bevy Cobweb, which I'll note is a fairly minimal dependency within this crate. The interfaces with Bevy Cobweb are fairly minimal, if that concerns anyone. And the final loadable is the instruction, and the instruction is where is a trait that you implement to get the entity command like mutability. And sometimes you actually implement instruction for components. If, for example, you want the component to be animatable, then you have to implement instruction, because instruction is a type bound on the animation stuff that I have. Here's an example instruction. So we have to apply the instruction, and then we have to be able to revert the instruction whenever it's hot reloaded. And then finally, you have to register the loadable with what kind of loadable it is. So this example is printing to the console. We can see saying hello, and it said goodbye before when let's see, it said goodbye when I deleted it, because it had to be reverted. So I deleted it, and then it said goodbye. Okay, so this is a screenshot here of, let's say, so we talked about a lot about what goes on inside the cob files, but what if you want to add logic to your scene, logic that ties in multiple nodes within your scene tree? And so what my solution for this was heavily inspired by the Sickle UI builder pattern. So we create a UI builder with the UI root extension, and then we load the scene and edit the scene. So we load the scene at the main cob scene with the root scene we pull out. So writing this, it spawns the scene, and then so the scene is spawned once we're inside this callback here. But the L here is a loaded scene helper that gives access to the nodes of the spawn scene. Once we exit this, the loaded scene will clean up all the artifacts from the scene, because at least in not when you're in a production build, you don't need any of the cached scene structure. But anyway, so once you've loaded the scene, you can edit the scene. And so here I'm editing a sub node within the scene. So I tell it the node name, which is as a child of the parent, and then that gives me another callback where I can do things like insert Bevy Cobweb reactive components. I can call onPressed using an extension method from my crate that uses Bevy Cobweb under the hood for reactivity. And so this function here, this system will run whenever this node is pressed. And then similarly, you can simply get a node and that makes it a little easier to, you can directly mutate it, but you only do this when you don't need to introspect even further into the tree. All right. So this is an example in the repo, or the repository. All right, so finally we get to the bonus slide. I'm very pleased to show you guys the bonus slide. I finished it last night. All right, so this is a little editor I built for COB files. And as you can see, when you save in the editor, it saves to the file. When you manually edit the file, it's reflected in the editor. And when you rapidly, you can change values within the editor, and they're reflected in the spawned scenes in the app immediately. And so this was a long design process to get this to work, but I'm very, very pleased with it. All right, that's the end of my talk here. The crate is Bevy Cobweb UI. Yesterday I published a version 0.5.1 RC.3. And you can also find the crate in the Bevy Engine Discord under Ecosystem Crates.
Awesome, Carl. My God, what a micro moment, like the second one already in this meetup. Just for the last minute, I wait until I show my editor. Thank you so much, Carl. This is amazing. Pretty cool. So yeah, we have a bunch of questions. For example, me included, I was wondering, as well as others, how did you get syntax highlighting for your own file format in your editor?
Well, all of the IDEs have some method of writing syntax, so I wrote syntax files. It's very painful, but it gives you what you want if you put enough time in. So there's syntax highlighting for VS Code, Vim, and Sublime Text. Although
nice.
the Vim one is, it needs someone to like redo it because it sucks.
Okay, well, to anyone watching and using Vim, this is a great way to start contributing. So how do you handle development versus production UI? I think you mentioned it in your talk that this is something that you distinguish, but the question is hot reloading development only? And are the options to compile COB, or are there options to compile COB into a production-ready format?
Yep. So there's the crate has a dev feature which gives you hot reloading, and then there's an additional feature which gives you the editor. And so in production builds, you just don't have those features, and it compiles out tons and tons of backend stuff that deals with hot reloading.
Yeah. Makes sense.
It's kind of spaghetti, honestly, because you got all these configs in there, but
yeah, of course. But is the format, is there going to be any difference to the format itself, or is it just the same file format that's going to be shipped?
The file format stays the same. It's just in how there's a lot of caching that you need to do to get the non-destructive hot reloading. Like, for example, you cache all of the entity subscriptions. So all the entities that load something subscribe to a specific scene node. And so you cache those when you're hot reloading, but you don't need that when you're in production.
Yeah, makes sense. Oh yeah, I guess you mentioned it in the beginning. What recent changes did you make inspired by Bevy UI? I guess that's how you'd call it.
So this COB format used to be all JSON. and that was painful, but it was better than raw Bevy UI. It was an increment over Bevy UI, but it was painful. And so when I saw Bevy UI, I was like, dang, that looks nice. I want to do that too.
Yeah. I mean, that's now that you presented it like that, I didn't even think that it might have been JSON before. Makes ton of sense. Yeah. Okay. And what's the most complex UI you built on top of this so far?
That would be
can you
the
show it, of
editor.
course?
That would be the editor. So this guy here, I built this. It took me, well, setting aside all of the logic for the editor. This was only a couple days, a few days, maybe 3 or 4 days, and part of that was building this little widget here. So this is the most complex UI. You can actually here, I show briefly the widget. So this is the editor widget, which is implemented in this demo example. So this is on the repo editor demo down here. Oops.
So this is like a text editor for the COP file itself?
No, this is the COB editor it lets you put widgets in there. You stick a widget in, and then it can edit the value within that COB file representation.
Ah, okay.
And so this is the extracted COB file for the editor extension file. I don't know why it's not showing up down here. So this was modestly complex. It was like a 1 or 2 days of work. So yeah, that's the complexity level.
Yeah. Okay, that's so cool. I think I would like us to move on to our panel conversation. I'm so happy for your presentation, Ko. I think there's a few questions left, but I would then mix it with the panel and hear everyone's opinion on your work there as well. So yeah, big hands again from chat to you. Thank you so much for presenting your work here and obviously for working on it. And thank you. So Zach, here you are. Bryan, welcome back. So what do you think about Cobweb UI?
That's very cool. That's so much nicer than Bevy UI already.
Yeah, I'm really curious how you like save and modify values in existing files. Do you keep track of like the span of it, of like where the text is? Like, how do you overwrite the file when you save in the editor?
I rewrite the whole file. So I have a when you parse it, it gets parsed into a COB representation, and so I can write that back to the file. So I have to extract all the comments in white space, which is a little tedious, but it lets you write back the almost the exact same file. So there's some lossiness in like number conversions. Like I automatically display like floats with no decimal point will be displayed as integers. So there might be some lossiness like that, but yeah, you just write it all back. And
so you also
that's automatic formatting.
Yes, exactly.
Yeah, there's not much auto formatting. I think that would be cool to add, but a lot of work.
Makes sense. Okay, so we have still a bunch of questions. I'm gonna go via the most voted one first. So if anyone's in chat wants to have an influence on that, go on the LiveAsk platform and vote on them. So the first one goes to Bryan. Does HIR deal with cases where, for example, a user does use Bevy prelude app as renamed Bevy app? Are there any strange edge cases you can't consider?
Yes. Okay. So, HIR is able to see past re-exporting and aliasing. I don't have it up right now, but if you saw the screenshot that I sent of the editor, you'll notice that when I specify hard-coded the paths to like the event type or the app type, I actually said Bevy_app crate and then the full path to the app definition. So HR doesn't care where you're getting it from. It just cares about the original location of it. So yes, it can see past it and it handles re-exporting and renaming just fine.
Yeah. So you don't see any edge cases with whatever Rust syntax is allowed to not be possible with the linter.
Yeah, mostly it's fine. The one edge case that I've encountered that still isn't fixed is there's an alternative method syntax, whereas compared to saying like my variable dot method, you can say the full path to the type colon method, and then you pass in a reference to that object. That is not yet handled because that's different from a method call. That's just a function call as the HR treats it. But that's the biggest thing that I've encountered so far.
Oh, okay. So this is actually something that you would have to consider in each lint yourself. This is not like abstracted away by the helper crates or the syntax tree.
Yes.
Okay. Interesting. So the next one goes to you, Zach. Have you tested how small you can get the memory overhead, excluding images and assets? Like, what's the smallest footprint, I guess, from any of these experiments that you made?
Yeah, so I actually haven't experimented with that at all. I haven't done any performance optimization for Bevy. I've just used it as is, and I've been pleasantly surprised that, thankfully, Bevy's already quite well optimized. So that little Pico demo that I showed before, that uses 63K of memory, and that's just Bevy on its own in its natural state. I do hope in the future to trim that down further. It would be cool to see if we get it even lower, but I'm honestly just shocked that includes the schedule graph, that includes all the systems, that includes the frame buffer that's actually rendering onto the screen. Like 63K is a lot in the embedded world, but for a full-featured game engine that's being shoehorned into the embedded world, that's pretty impressive.
Yes, absolutely. That's pretty cool. Brian, what is going to be the hardest kind of lint you see as a North Star goal?
Ooh, like what goals do I have for linters? I don't think there's one specifically that is like in my mind as that's what I'm aiming for. As I mentioned before, trying to like automate migrating to new versions of Bevy, I think that would be a really, really fun project. A hard reach, but I don't have a specific lint in mind for so that'd be super challenging.
Yeah, I mean, now that you pointed it out, is there for the existing lints already suggestions implemented, or is that also something that's still out there?
Yes, a lot of the existing lints have automatic suggestions, some of which aren't machine applicable because they require importing and stuff, and we can't easily suggest adding that. But yes, there are existing suggestions.
Okay, cool. So for anyone who needs like an example, they can look at that and see how that's implemented. Yeah. Are you also seeing an editor? Well, this is probably outdated now that we've seen an editor, but the question was, can you see an editor being built for this? But it sounds like something that you really just added very recently, right? Is there more, like, is this going to be a proof of concept thing, or are you planning to build this out further?
I think
you're muted.
This is a very basic proof of concept, a 6-day throw it together for this presentation. I have some small things I want to do with it, but honestly, the raw cob files are so nice that I mean, I'm not super driven to develop it, like to become something really big. But of course, I'd support anyone who wants to tackle that.
Hmm. Yep. Gotcha. I mean, it's definitely a nice add-on, and it's also a cool use case to see how easy it is to build something like that, right? A great example itself. There's another one for you. So does Cobweb use Bevy Asset Loader under the hood, or did you implement this with manifests yourself?
So the manifests are all built in. I don't use any. My only dependency is Bevy Cobweb.
Okay.
And Bevy, of course.
Yeah. I think it's probably because there's a lot of similarities between the asset loader manifest files. I'm not sure if it's called like that, but you can also essentially have these collections of assets in there, right? But yeah.
But my manifests include manifest keys, so it's kind of custom.
Yeah. Okay, cool. Zach, this one's for you. What game would you make for the GBA once your new still work is done?
Oh no, you can't ask me that. I don't have ambitions. Honestly, I have no idea. I love the idea of just making little toy games. I think like a few game developers here, I'm more drawn to creating the engine and the tooling than I am specifically making the games. I think it's a curse some of us bear, where we're more interested in writing the code than actually making a game.
Yes, I think that's a common pattern I see. Hey, I wanted to use Bevy, but it lacked this UI thing, and here I am a year later.
Exactly.
Hey, wouldn't it be cool if we had some lints?
Oh yeah. Damn, I tried to implement events, and then
Here I am doing laundry.
Yeah, it was just a theoretical. I think Alice or something like that wrote down a design document for what the Bevy CLI would look like. That's what originally stemmed this, a command line interface for working with Bevy projects. And one of the bullet points that she wrote down was, hey, maybe custom Bevy lints, and I just hit the ground running and never looked back.
Nerd snipe.
Yeah, totally. I mean, it's so good to have so many people be motivated by these things, right? This is how this whole ecosystem grows and gets these very cool tools. Zach, another one for you. What's the init heap doing? I think this is a function that you showed in one of your snippets.
Yes, I can just very quickly show that. It's very small. So all that little. I'll just share my screen.
Wait. Where is your screen? I'm gonna put it up if I see it. Here.
There it is. Yeah, so all that function does, I'll hide that so you can see the whole thing. It just makes an array that's as big as my heap and gives it to a no STD allocator that was lovingly provided by Crates.io. So basically nothing. It's a very, very simple allocator. It's probably the kind of allocator you'd write in your first year of computer science.
Yeah, very, very cool. So how much heap did you have here for the Pico?
So if I go right up to the top, I gave it 96K to play with, and it used 63. I arrived at that number because I gave it 32 and it didn't work. So, so I just kept upping that number until it started working and it compiled.
Nice.
But even when it didn't work, it was still really cool because I gave it 32K and the program didn't work. It's like, oh, that means it ran out of memory. That means it was allocating.
Zach, I'm noticing you have this include bytes macro for a bevybird.dark.data. What file format is that?
Yes. So a .data, it's just an image, but it has no compression or anything. It's just 1 byte per pixel and as many pixels as you have in the whole image. So it's a 64 by 64 image of, actually, I think I've got it there. It's this little image here, but just 1 byte per pixel. And since it's black and white, that's 1 byte per bit. So it's very wasteful as an image format, but very convenient for what I need to do.
And then you have hard coded the dimensions to know how much X and Y, or is that in there?
I haven't started with the assets side of NoSTD, so I'm just cheating.
Totally fair. Totally fair. That brings us to another, probably not 100% serious question of when Bevy on ATMs. I guess we can take it seriously. Do you know anything about the constraints of systems like that? Like if we are talking 63K, then how much is that compared to other like embedded systems?
So for really small IoT devices, that's probably on the fatter side of things. But for something like an ATM, yeah, no, that actually is totally feasible. ATMs already I think they'd actually be running like embedded Windows even. Like they're already quite high level machines. Pretty UIs for them as well. So kind of seriously, yeah, embedded Bevy is a reasonable target for an ATM machine. You want a pretty UI, but you also want something that's very low level and has minimal dependencies and total control. You don't want a Windows update popping up halfway through a financial
or a blue screen. Yeah,
exactly.
So cool. Cobweb UI on an ATM. Here you go. Okay, Brian, here's another one for you. Will this still work if my project... Oh, wait, we already had that. Sorry, I should have read that. There's actually someone asking if you're mentoring newbies to work on this. So I guess you already answered that. That's a clear yes.
Yep.
So please go ahead, reach out and help support making the Bevy Linter even stronger. The cobweb editor is super cool. How do you handle rewriting cob files when you save that? I think maybe this was Brian then.
It was.
Okay, I guess we kind of answered that already, which means we are actually at our last question from the Q&A platform. Ko, what's next for Cobweb? What do you still have on your roadmap?
So there's one big feature remaining for the cob format. It's called scene macros. So a scene macro lets you, it's kind of like a function, looks like a function, and it lets you construct a scene chunk, I guess, that can be pasted onto other scenes. And since it's function-like, you can insert parameters that get injected into the definition of it. And so this is required to do cob-oriented widgets because it lets you have a base definition, and then you can override parts of the widget, and then stick that widget in a new scene, and then you've got a customized widget that is compatible with, on the Rust side, the components and so on that let you set up the widget and use it to add the logic.
Yeah. So like what other engines call prefabs, which can allow you to override and extend them, right? That's cool. Yeah. Did you look into how there is some concept for such stuff called patching in the BSN format, right? Do you draw some inspiration from that?
It doesn't make much sense to me. I don't really understand it. Maybe it's great, but it didn't really click with me. I think it's really, the patching is Rust oriented. So it's something you do the patching in Rust, whereas this is all going to be within the cob files. So it's like a lot of data pasting. So you copy and paste the data in the cob representation. So it's a little different, but I assume the patching is going to serve a similar purpose. Yeah.
Yeah. Okay. Pretty cool. So yeah, we are out of official questions. So I guess my last one personal question to you guys is, what is the most exciting thing you are waiting for in 0.15? Cody, do you want to start?
Oh, right. So entity commands gets a new little function that snuck in there accidentally called
Oh, who
command
did
mute.
that?
It returns a mutable reference to commands. And this allows you to do, oh, I don't have presenting up, but it allows you to construct builder patterns based on entity commands, because it allows you to, anyway, it's complicated, but it was really, really important for the ergonomics.
So that makes your builder pattern that you already built for the UI better, or just
Right.
under the hood improvements?
So the old builder pattern only let you edit the scene nodes, and then you'd get a callback. But with the mutable reference, it lets you do get on the node, and then the get returns a new struct, which contains which lets you do a builder pattern directly on the gotten node.
Okay, that sounds pretty useful for your use case specifically, of course. Yeah, so there's going to be a matching release then pretty soon of your libraries as soon as we have 15 out.
Of course.
Awesome. So that, Zach, what about you? Aside from the fact that 15 rolls out the first bunch of actual contributions to the no-stud effort, right?
Yeah, first couple of little ones. Well, I say little, that we moved from this era to derive more, and that ended up being, I think, like several thousand lines of code change just over the whole Bevy repository. Just that one little thing that was a bit viral. Honestly, I'm not sure. I think I suffer a little bit from just because I work on Bevy main directly. I think it's very easy for me to just sort of forget what comes out with each release. It really hurts when I'm writing migration guides. So I'm like, oh yeah, you do this and then I find out later that, oh, actually that was added like a week ago. So you need to write the migration from this other thing that existed 6 months ago instead. So honestly, I'm not sure. I think I'm just excited at the idea of it releasing at all, just because I think this has been a massive release. The release notes have taken a huge amount of work and effort from everyone to write. I think I'm just excited to see it release so that we can, get started on 0.16. Just keep that ball rolling.
Oh yeah, that's the spirit. After the release is before the release, right? Okay. Bryan, what's the most exciting for you in this?
So I'm in a very similar boat where I haven't really tried writing a game in Bevy for months at least, so I don't really know what's coming out. But required components, I think, might be one of my favorites, because I remember working with bundles and being frustrated by the amount of just typing that I had to do. I felt like I was writing in Java. We don't like that feeling here. So it would probably be required components, just because I think I like how it makes things a lot easier. What about you, Stefan?
Oh yeah, well, the required components is obviously the easiest one to pick, but my personal like teeny tiny one that I want to point out is the feature that allows you to bubble up observer events, actually, because we actually use observers in a lot of the UI, and to have to manually basically do that right now is going to be such a simplification once that stuff just gets automatically bubbled up. So that one, very, very tiny but important. And yeah, I would say aside from that, I'm probably exactly on the other side of the fence. For me, it's really like once the release notes actually drop, that's when I probably noticed a bunch of the things when they were merged, but right now it's really hard to remember like all the good stuff that is now going to come together in this one humongous release, right? So for me, this is going to be like a little Christmas. Let's hope it's not, it's hopefully a little bit before Christmas that we actually get to see it. And yeah, and then I'm going to be unwrapping this release by reading the release notes on day one, and I'm sure, based on experience, there's going to be a lot of shit that's going to be super exciting, and then a lot of stuff that's going to be breaking my neck until I can actually finally use it in the games. So yeah, I'm looking forward to that. Okay, any last notes? Anything that we missed?
No, I don't think so. Thank you very much for having us up. This has been an awesome experience.
Yeah, thank you. It's been awesome.
Thanks.
Thank you guys for making this possible, and obviously a huge shout out to you, Zach, to basically cut your night short for this. It's really appreciated. And so yeah, I'm going to wrap up. Good morning. Okay, great. I'm gonna drop you guys out. I'm looking forward to hear the progress on your stuff, and big hands from chat to all of you. And thanks for everyone to come here. And let me pull up my thank you slide. Where are we? Here we go. Thanks for joining. This was the 7th meetup. I'm super excited to keep doing this. So if there's any project that you came across that you think is going to be just waiting to be presented here, please reach out to me. If you have a topic of your own that you would like to present here, then please reach out to me. And other than that, make sure to subscribe to our YouTube channel and to our meetup group to not miss any of these meetups. And if you are interested in what kind of games that I mentioned are built on Bevy that we built, check out rustunit.com. And thanks everyone for coming, and have a great rest of your day.